Welcome back. So we have another problem which tests on application of this formula for finding residues, that we have to find the residue of the function f of z defined by 1 over z squared plus 1 cubed at the point z equals to I. So the first step is to find the poles of this function, and then once we have obtained the poles, we concentrate on this given value of z. And actually, this should be one of the poles for this particular function. So let's see how we solve this. So first step, let's find the poles. And poles are found by taking the denominator and equating to 0. So which means we'll take z squared plus 1 power 3, we equate it to 0. And you see z squared plus 1 can be written as z plus I times z minus I. So we raise this to power 3, we get 0. So this is the same thing as saying z plus I times z minus I. So this power 3 is equals to 0. So I'm using lots of indices that if I have a power n, b power n is the same as ab power n. So this is the property that I'm trying to apply to these brackets. So it should be very easy to see that z equals to negative I and z equals to I are the poles of f of z, each of which is of order 3, because the powers for those terms were each 3. So that's the first step. So because the question specifies that we have to only concentrate on finding the residues at z equals to I, so that's the only part that we take care of, this part. So we'll say here z equals to I, as specified in the problem, is a pole of order 3 for this function f of z. Now, residue at z equals to I, so by definition will be given by 1 over, so n for this case, because the order is 3, will be 3, so it will be 3 minus 1 factorial, and then 3 minus 1, 3 minus 1, z minus I power 3 times f of z. And by definition, this will be carried at z equals to I. So this will be 1 over 2 factorial. Now, second derivative, and then we have z minus I cubed times f of z was given by 1 over z squared plus 1 power 3, and that can be written as z minus I power 3 times z plus I power 3, and this should be evaluated at z equals to I. And you see by doing this product, this bracket and this bracket cancels out. So the problem reduces to finding. So 1 over 2 factorial is just 1 over 2. Now d squared dz squared of simply the function 1 over z plus I power 3. And then all this should be done at z equals to I. So that is what we have. So let's calculate the derivative, second derivative of this function. So the first thing we have to calculate d dz of the function 1 over z plus I power 3. This can be written as d dz of z plus I power negative 3. So using chain rule, so we'll have negative 3 and then z plus I, subtracting 1 we get minus 4, and then differentiating inside with respect to z we get 1, so it doesn't change the value. So this is what we have. So which means the second derivative of 1 over z plus I power 3 will be d dz of this first derivative, which is minus 3 z plus I raised power minus 4, which will give us, using chain rule again, so we'll have minus 4 times minus 3 is 12, and then z plus I, subtract 1, we get minus 5. Differentiating inside, we still get 1, so it doesn't change the value. So this is the value of the second derivative of the function 1 over z plus I power 3. So which means that the value of second derivative of the function 1 over z plus I power 3 at z equals to I is the same as 12 into I plus I power minus 5. So they're same as 12 over, so this is the same as 2I power 5. Now that will give us 12, 2 power 5, and then times I power 5. You see I squared is negative 1, so I power 5 can be written as I squared times I squared times I. So this negative 1 times negative 1 times I, because it's just I. Two power 5 at 2. So that's 2 I. And then 12 over 32, we get 3 over 3 over 8. I, but then we can rationalize, we can remove this I from the denominator by multiplying both sides by negative I. So that will give us negative 3/8I. So, which means that residue at Z equals to I is given by, you see from this point, we had 1/2 times this value. So it's given by 1/2 times this value, negative 3/8I. So that is given by negative 3/16I. So that forms the value of the residue of that function at the point Z equals to I. So that is the solution. Thank you.